Okay, so now that I have sketched it out, I will do my counting. So I do my counting, right? I just see from here to here. So this way I add 8 units. So when I add 8 units, oh, my drawing a bit off. Okay, never mind. I just write down first. My drawing is a bit off. This is 1. Okay. Then from here to here, drop 2 units. So it's 1 and minus 3. Alright, so what I'm going to do is, see, beautiful, I got these 2 points ready. I have point C, point D. I can easily find the equation of CD. So let's find the gradient. Okay, I'm going to fast forward. So my gradient is minus 3, 1 minus 4. So my gradient is 2. Make sure you can get that, okay? Y2 minus y1 over x2 minus x1. Then I'll choose this point here. So I'll do my y equals to mx plus c. So we will have y equals to 2x minus 5. So this is my answer for equation of CD. Can, right? My drawing a bit off, okay? It should be like somewhere like maybe here. But I'll be saying it now. Okay, I don't know how to improve this. Okay, well, I give up. But anyway, agak-agak, you can see the position from there lah, huh? Okay, so a bit off the position. But anyway, you can just count lah. The best part is parallelogram, 2018 also, we just count. Alright? Okay, point C. I mean part C. Part C feels like there is more vectors involved. What do they want? Point X, right, is the... What? Point X is what? Point X is where the diagonals intersect. Oh, die already. Okay, very ugly. I better improve this. Wait, let me draw properly. If not, later y'all cannot visualize. Can I move the axis instead? Let me try. Wow, I'm a genius. Can already write like that. Okay, so I move the axis. Okay, so now what I have, actually you want to remove the axis also can lah, okay? So they want x is the diagonals intersect. Okay, let me draw the x here. Diagonals here, diagonals here, right? So the diagonals intersect. So this one here is point x. Okay, so the diagonals intersect. Anyway, the diagonals, okay. So they want xc, yeah? So xc is like that, this part over here. So actually what you will do is, right, what you need to do is you actually have to go via the vectors law. So you see, what vectors do I have? I have BC, all right? I don't have, what do they want? So I need to find a few things here. So what we have here is that you can see, since it's the diagonal, right, the important concept is XC, right, is actually half of AC. Okay, half of AC. So I need to find what is AC lah. Okay, so let's just understand this logic, okay? So I got coordinates A and coordinates C. Let me just very quickly draw it out. So coordinates A, coordinates C means I have OA, OC. So OA is minus 7, minus 1, correct? Minus 7 and minus 1. Then OC is 4 and 3. You see, now what am I doing? I'm turning my coordinate geometry back into vectors again, correct or not? So coordinates become column vector. So if I want to find AC, AC is what? AC is AO, that's why I swap, and then OC, like that. So that's 11 and 4. So if I just want half of it, then my XC, right, just right on top, okay? So my this one here, right, will be what though? My this one here will just be half of this, right? So 5.5 and 2. So this is what I'm done with. Okay, so this is my answer. Why so trembly my hand? Nervous, Okay, so this one is what I have. So this is my answer for the first part. Okay? Okay, then the next part is find the position vectors of x. So what's position vector? Position vector is OX law. So that means you have to use what? So you draw another triangle again. Okay, so you draw another triangle. So remember you want OX. This is the question. Okay, so you draw a triangle. That means you have O, you got X. So notice one thing. See, related. So use XC. So XC is here. XC I have is this one, right? This one is XC, right? Okay. Then after that, you got OX. OX, use what you want, ma. OC is what though? OC is 4 and 3, like that. Okay, so how do you find OX? OX is OC plus negative 5.5, negative 2. Saw that? So that means at the end of the day, it will be what? Negative 1.5 and 1. Then did they want it in coordinates or they want it in column vector? Position vector. Okay, so we are done with this question here. Okay, so mixture of coordinate geometry together with your your what you call that, together with your column vectors. Okay, coordinate geometry and vectors. So very common, they like to test parallelogram, okay?